Hello, students. In this section, we're going to talk about some of the applications of trig functions. You have already seen how trig functions, especially the sinusoidal functions, are used to model several situations in our real life where there is a periodic pattern in the things like temperature, hours in the day, even our gas consumption in a year has the periodic pattern. Trig functions are also used to solve many other real life situations, and we're going to talk about them here. So we will see how they're used to solve right triangles and how solving the right triangle actually leads to figuring out the height of some tower or building, something that is not easy to measure by hand. We actually can use the trigonometry to measure those things. Angles, um, if you're looking down from the top of a lighthouse to a boat, you can figure out the distance of the boat from the base of the tower and things like that. So we're going to look at some real life situations. So first, in general, how we use trigonometry to solve right triangles. When we say solving right triangles, we're talking about finding the length of the sides and the measure of the angles. So as we know, there are three sides and three angles in a right triangle. We do have Pythagorean theorem to solve right triangle only to the extent that if you give me two sides, I can figure out the third side. But with trigonometry, we can go farther. We can, just by knowing one side and one angle, you can basically find out the other two sides and the third angle. So again, all of this trigonometry works only for right triangles. Keep that in mind. We are going to talk about solving oblique triangles, which are not right triangles, later on. Right now, we're talking about trigonometry. It's strictly for right triangles. So let's look at this triangle here. It's a right triangle, and I have to find the length of sides A and B and the angle B. So first I'm going to just label this as A and this as C. So let's go ahead and find the angle B first. And if you know two angles in in any triangle, basically you can find the third angle because we know that all three angles in a triangle add up to 180 degrees. And when you have a right triangle, I even go one step shorter and say that if one angle is a right angle, the other two must add up to 90 as well. So I can actually find the measure of angle B by simply subtracting 65 from 90 because together they should also add up to 90. You could still set up angle B plus 65 plus 90 and solve for angle B, but this would just be a step shorter. You will still get the same answer no matter what. Now let's go ahead and find one of the sides. We can choose any. I'm going to choose, let's say, side A first. Now for my angle 65, this happens to be the opposite side, and 10, which is the side C, is the hypotenuse. It's the side opposite the right angle. One thing that we will be consistently doing is we will use the uppercase letters to represent or to name the angles, and we use the respective lowercase letters to represent the length of the opposite sides. And I'm sure you know that there's a relationship between the angles and the length of the opposite sides. Bigger the angle, longer is the opposite side, smaller is the angle, shorter is the opposite side. So let's go ahead and first find side A. So since side A is the opposite side and I already know the hypotenuse, the trig ratio that I will use is sine. So sine of 65, it's important that you put them in the correct order. Opposite over hypotenuse, so A over 10, which means A is equal to 10 times sine of 65. When you put it in your calculator, make sure that you are in degree mode. So let's put it in. I got 9.06 because the question is asking me to round to 2 decimal places. There's no unit given here. Otherwise, I would put the unit. Side B happens to be the adjacent side, and I'm going to use the 65 angle that's given. I could use angle B also, which is 25, but usually we use the measurements that are given to us unless we don't have a choice. In this case, it would not make any difference because you didn't do any rounding for angle B, so your answer will not be off if you use sine of B instead of cosine of 65. Sine of B would be sine of 25. Um, I'm going to use cosine, so 6 being my, B is my adjacent side over the hypotenuse, so B is equal to 10 times cosine of 65. Let's put it in our calculators, and that comes out to be, rounding to 2 decimal places, will be 4.23. Okay, so we have solved the triangle. We were given 2 angles and 1 side, and we found the third angle and the other 2 sides. So like I mentioned before, this is how we're going to utilize the trigonometry, is to find the height of really tall things or things that are not easily measurable. Two types of angles we will discuss: angle of elevation and angle of depression. So angle of elevation is when you look up, look above the horizontal line. Like when you look straight, your eye just looking straight will make a horizontal line, but if you look above that horizontal line, that is called an angle of elevation. And if you look below this horizontal line, then you are looking down. That's the angle of depression. One thing that we will notice here, that the angle of, in this case, in this diagram that you can see, this angle of depression and angle of elevation are equivalent because, or congruent, because these lines are parallel lines, and this becomes the transversal, which makes these angles alternate interior angles. So sometimes when we are given angle of depression, we label this angle of elevation as the same angle just because these are congruent and we need an angle inside that triangle that we're using. Okay, so let's look at some situations here. You want to measure the height of this tree, and the person walks to a point 30 feet from the base of the tree. The measure of this angle of elevation from the line of sight to the top of the tower is 57 degrees. We have to find the height of the tree. So first, obviously, we know that the tree is making a right angle with the ground, making this a right triangle. For this angle, in reference to this angle 57, 30 degree is our adjacent side, and X, or the tree, is our opposite side. So the trig ratio that we're going to use, sometimes it helps people to use this SOHCAHTOA acronym. And adjacent and opposite are the two sides that we have here. One is given and one we're looking for. So that means that we should use tangent. So tangent of 57 is equal to opposite over adjacent. So I will multiply 30 to both sides. And let's put it in our calculators. And I'm going to round this to 1 decimal place because there were no instructions given. When there are no instructions given, and all the measurements were in whole numbers, then it's okay to just round to 1 decimal place. You always want to just be one step more precise than what the data is given. Okay, let's look at B. A radio tower is located 325 feet from a building. From a window in the building, a person determines that the angle of elevation to the top of the tower is 43 degrees and the angle of depression to the bottom of the tower is 31 degrees. How tall is the tower? So what I'm going to do here is, you're already standing on a building, right? The building also has obviously a height, right? And then there is a tower, a radio tower, which is taller than the building. And you are looking up on the top, and you're also looking down at the bottom of the tower. So when you are, well, you are first located, the building that you're on is located 325 feet from this tower. And when you look up from, let's say this is the window. When you look, let's say you're on the top tower, top floor of this building. When you look up, the angle is 43 degrees. And when you look down at the bottom, the angle is 31 degrees. So you have to find out how tall is this whole thing, right? This tower. So if you notice here, what we're going to do is we're going to split that into two right triangles. And let's say we call this X and this Y, and we're going to solve for this X and Y. Now, if I separate these triangles, basically you have two triangles. You have one triangle that has this angle 43 degrees. This is what you're looking for, and this horizontal distance is 325 feet. And you have another triangle where this angle is 31 degrees, this is 325, and this is Y. So in both of these triangles, you are looking for the opposite side and you're given the adjacent side. So I'm going to go ahead and label that. So this is your opposite, this is the adjacent, this is the opposite, and this is the adjacent. So we're going to use tangent for both of these. So I'm going to pause here and let you guys determine the tangent equations for these. Okay, so this is tangent of 43 equal to x over 325, and this is tangent of 31 equal to y over 325. X here is 325 times tangent of 43. I'm doing both simultaneously because I'm going to actually put them into the calculator together. It's best to not round and just, round at the very end. Basically, I have to add these two up, right, to figure out the whole length or the height of this radio tower. So I am going to just put them in the calculator. In fact, I can factor out 325, but let me just write it like this. And go ahead and put it in your calculator and round after you get your final answer. I'm rounding it to one decimal place, and I'm getting 498.3 feet as the combined height. X and Y add up to 498.3 feet.